Okay.
Wait a minute.
Really? All right. So let's talk real quick. Anybody have any questions really on the first page, 1 through 9? Anybody have any questions on 1 through 9? Yes. Okay, so again, there's lots of good ways. I'm actually kind of glad we're reviewing this because you're supposed to remember there's a relationship between the interior and the exterior angle, and they're always supplementary. The exterior angles always add up to what?
360.
360. So let me see if I can tell you something. For example, number 2, how I would prefer that you do this is to say that the measure of each interior angle is 172, right? That means that the exterior angle is how much? Good, 8 degrees. All right, so if the exterior angle is 8 degrees, that means the number of sides would just simply be 360 divided by 8. All right, which is 45. All right, that's much easier than if you do n minus 2 times 180 divided by n is equal to the exterior angle or the interior angle. Everybody see that? All right, hopefully you are paying attention. That's just a really quick way of doing that. Yes, sir. Number 4, given parallelogram ABCD and C is 5, 4, find the coordinates of A if the diagonals AC and BD intersect at 2, 7. So on this, I think the best thing to do is just kind of draw it out. I think would be good. You can see it better. All right. Let me just go ahead and. All right, so if I'm looking at this, let me see. And so C is 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4 right here. And then the diagonals intersect at 2, 7. So let's find that. 2, 1, 2, 3, 4, 5, 6, 7. All right. That means that's half of the diagonal. Do you agree with that? You with me? And so this point right here, we said was 2, 7. This point right here was 5, 4. That means the other endpoint, right? I have to go 3 back, and I have to go up 3. You agree with that? So that's why the answer was what? Negative 110. All right, because the intersection is the midpoint. You with me? All right.
How do you know, like, to go back 3 and up 3 instead of going, like from 5 to 4?
Well, do you agree? The only way to get from here to here is this direction, right? That's what I'm saying, right? So that is the midpoint. Agreed? All right. Anybody else? We're talking about 1 through 9. All right, I'm pretty happy. Let's go. Next page, 10 through 15. Everybody pretty comfortable with that? All right, I'm pretty happy. Next page. All right, let's take a look at 24. It says ABCD is a parallelogram with diagonals that intersect each other. If AE is x squared and EC is 6x minus 8, that just means they are equal. Do you agree? So we would say that x squared is equal to 6x minus 8, right? Which means now it's quadratic, solving a quadratic. So let's see what we have. X squared minus 6x plus 8 plus equals 0. And so now when we factor that, we end up with x minus 4.
That's what I got with the answer. It said like 8 and 3. Yeah.
And you should have checked to see what the question was.
That was like,
Are you saying 4 and 2 is the right answer?
yeah, I got, that's what I got.
But then it says 8 and 2.
Yeah.
Because that's not the question. The question is, what is the value of AC? It doesn't say what is x. And again, I keep trying to tell some of you guys, that's part of your problem on your test. You don't bother reading the question. So you just solve for x and think you're done. That might be the answer. Agreed? It might not. All right? So how do they come up with those answers? Well, if x is 4, then x squared would be what? But that's half. Do you agree? So that's why the answer is 32. Or 2 squared is 4 times 2, 8. You with me now? Makes sense. Try to remember. See if you answered the right question. Yes, sir. 21. Let's look at that. So there are how many? 1, 2, 3, 4, 5, 6, right? So the interior angles would add up to 720, right? So 1, 5, 2, 7, 6, 9. You're adding those up. And you're setting it equal to what? 720. What is that? 30? Anybody else get 30x? And then, what was it? How much? And so now x equaled how much? 30. So that was x, and then they wanted each angle, right? So then you have to plug it in, which is kind of annoying. Right? Yes. Let's look at 29. Well, that's on the next page. That's okay, though. Anybody else? Isn't 28 on the next page? Yeah, so we're sticking with this page. We're going page by page. Let's look at 22. What? What? All right, so I'm on 22.
Oh, I can't add. That's why I did that.
Find the measure of each exterior angle. Well, the exterior angles always add up to what? So it's simply 360 divided by the number of sides. How many sides are there? 2x sides. So the answer is just what? 180 over x. That's just to see if you're paying attention, I think. Make sense? Anybody else now on this page? All right, let's move forward. All right, tell me. Let's look at 28. Okay, so on this one, the diagonals of a rhombus intersect at E. All right, so let's just, to me, I think it's important to draw A, B, C, D. Now remember, you guys, please tell me what a rhombus is. No. Just simply the sides are what? You're right, but you know what I mean? I just want you to tell me that a rhombus is a parallelogram that has what? Equal sides. That's all it is. All right? Now, there's something special because I try to draw a rhombus there, and so what it demonstrates is what's true about the diagonals. They are perpendicular. Thank you very much. All right, they are perpendicular. Now, again, I always try to remind kids, the hardest thing for me was trying to keep track of all the information. You can either memorize all the information or on the test draw a rhombus, and what can we conclude about all those triangles? They are congruent, right? And if they are congruent, that forces these angles to be equal, which means they're all right angles. So everybody with me? I just think it's important to be able to do that. You're not going to remember all the information. Well, some of you have that capacity to do that, but most people don't, right? And plus, in a couple months, they might ask you a question. You want to be able to sit and reason through it, all right? So our rhombus is what? A, B, C, D, right? So let's go ahead and call this A, B, C, D, E. Again, A, B, C, D, and then E is here. Now it's just a matter of looking at BAE, right? So here is BAE, and here is ABE. Well, what's true about those two angles, guys? No. They're not equal. What are they? Complementary. Thank you very much. Now that's to me is an unusual question because I would never ask that. I would just ask you to understand how we know that. This angle down here is how much? 90. Therefore, the other two angles have to add up to what? 90. All right, so what they're doing is they're saying one of them, BAE, is 2/3 of that. So that's x, and that would be what? 2/3 x. And then I add them together, and they equal what? 2/3 x plus x equals how much? 90. Everybody with me? So 5/3 x equals 90. So x is equal to what?
Where did you get 5/3?
Are you having trouble with 1 plus 2/3? Right? 1 plus 2/3. Today is 5/3, right? So now we're multiplying by the reciprocal, so we get 270 divided by 5, which is the same as 54. Thank you. So x is 54. All right, it says find BCD. So wow, BCD is not what they're, sorry. BCD is this angle right here. Everybody agree? All right. Now, how exactly do I do that? Well, what is x? 54, right? So if this angle, now I'm going to erase a little bit right here. If this right here is 54, this angle right here is 54 degrees, then what's this angle right here? Is that right or not?
No, I think it would be BAE is 54, and then the other one's 2/3 of 54. AB, that's ABE.
Did I write that wrong there? It says BAE is BAE is 2/3 of So look right here. So I'm just going to make sure I'm doing this right. BAE is equal to 2/3 of ABE, right? So ABE is what? X, right? The other one is 2/3 of that. Do you agree or not? Right? Now, come on now, you guys. I'm just telling you, I think it's easy, but if you don't ever do the problems, you don't ever look for your mistakes, you don't ever see what I'm thinking about, you know, you're not, it's going to be tricky tomorrow. That's what I'm saying. I think I'm correct. You know, is everybody agreeing with me now? That's 54. So this angle right here has to be 54, right? Which means this right here is what? 108. Which means this down here would have to be
No.
72.
72. Thank you. 72 degrees. That's what I think. All right. Lots of ways you can come up with that. Lots of ways. All right. We could have come over here and said this angle right here is 36 degrees. So this angle right here is 36. And then those add up to 72. Same thing. All right. Come on. I'm telling you, if you're not drawing things out, you're not visualizing, it's going to be tricky. All right. Somebody else on this page. 29. The diagonals of a square. All right, so what's true about the diagonals of a square? They're equal. Do you agree? So here's what I'm looking like. Drawing a square. And here is A, B, C, D. And they intersect at E. And AE is 2. Therefore, EC is what? And they're all what? They're all 2s. All right, so now we have a problem, right? This right here is unknown. So I have to do Pythagorean Theorem, right? Which is just 2 squared plus 2 squared. Square root of 8. 2 radical 2 is one side. So all 4 sides would be 8 radical 2. Come on, that's just good math right there. I'm expecting you to be able to do that. All right, here we go. 31. Oh, this one's a really nice problem. Okay, so here's what I want you to do. Draw from here to here. This would be nice. And so then they want you to just realize that this is a what? Yes, mid-segment, right? So let's see what we're doing. So it says AB is 6.
They're all 6.
So that's 6. And then it says let me think about that. Oh, this is a very good problem. Look up, guys. This one's kind of hard. All right. What if I told you that? I want someone to try to tell me.
Is it 9?
Yeah, it is. But the question is, how do I know what AD is? Somebody tell me what that is. What is? Tell me how.
So, BC is also 6, and I put 6 on the sides. So I found the half of this trapezoid. So that'd be 3, so it would be 9 here. What AD would be 12, and 9.
Okay, what I really want you to kind of look at is this. Does everybody agree this is a hexagon, right? So if I draw from here to here, and I draw from here to here, this is the main thing. What's true about all those triangles? Does everybody agree with me? They're equal. Hexagons are really cool shape, right? It occurs in nature a lot, all right? Because if you draw a hexagon, it divides it up into what? 6 congruent triangles. Does everybody agree with me? If there's 6 congruent triangles, then this right here is what? All the sides are 6s. Does everybody agree with that now? That's how we know that this from here to here is what? That's how we know that's 12. Everybody with me? And if that's 12, then this is a mid-segment, which is just the average of 12 and 6. All right, that's a really good problem. 12 plus 6 is 18 divided by 2, which is what? 9. That's a really good problem. Yes.
How do you know all of the signs?
Very good question. So here we go. Let's review that. All right. So let's talk about this. So the interior angles of a regular hexagon would be the exterior angle. Let's just do it this way. The exterior angle would be 360 divided by 6, right? So that's 60. Do you agree? Which makes this what? 120. You agree with me? So all of those angles are 120, right? So if I'm going to draw this back in now, you with me? These all the way around is 360, right? So if I do 360 divided by 6, that forces this to be 60. 60. You with me, right? And then this is equal to this. You with me now? So that's why it's an equilateral triangle. All right? It's an equilateral triangle. All right, so that was excellent. All right, somebody else now. What? The vertices of a trapezoid, blah, blah, blah. Find the length of the median. All right, let's try to do this. 10, negative 1, 6, 6, negative 2, 6, and negative 8, negative 1. Now, I'm not sure why this one was that bad, right? We're just finding the distances and averaging them. You with me or not? So the distance from negative 8 to 10 is 18, right? And the distance from negative 2 to 6, is that right? 8. So 18 plus 8 divided by 2.
Oh.
Thank you. Somebody else. I like it, guys. Yes. 33. Show me whether quadrilateral or vertices of a kite. So a kite, remember, you just need consecutive sides are congruent. You with me? So we're going to draw this out. All right, 0, negative 1, negative 4, negative 3, negative 5, 1, and 1, 7. Kind of looks good, but maybe not. You with me? So I'm trying to find what? I'm trying to find this distance right here. Trying to find this distance, you agree? So I went up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? So 6 squared plus 6 squared. Right? And then here I went 1, 2, 3, 4, 5, 6, 7, 8, and over 1. 8 squared and 1 squared. Are those the same? Did I plot those right? I would say no. Is that what the answer was?
Mm-hmm.
Not a kite? What?
How did you know to do that?
I'm just doing the distance formula, right? You agree with that or not? I'm just, because I'm trying to see, yes, if it's a kite, consecutive sides are congruent. Is that what you're asking me? All right, somebody else, guys. All right, flipping the page. Oh, sorry. Yeah, let's go to the next page. No, you're good. Perfect timing. 36. Okay, it's a kite, right? So, what is this angle F going to be? Yeah, you agree? So now you just add them up, set them equal to 360. Do you agree with that? Right, so 1, 2, 3, 4. Uh-oh, no. is that 2x, right? And then 10 plus, is that right? 150 equals 180. Somebody else get that? So x is equal to 15. Anybody else get that? What?
How did you go from like adding x to 5?
Oh, it's 360. I'm sorry. Thank you. It's not 180, it's 360.
And how did you get 150?
Didn't I add 140 plus 5 plus 5? Right?
Oh, yeah.
Sorry, that was my fault.
Oh.
That's my fault. I made a mistake with the 180.
Then would it be? Oh wait.
With
Oh, yeah.
what? I'm just adding the x's. You add the x's for me. What do I get? What do you ask? Do you add the numbers? You got 150, right? Set them equal to 360. Yeah, no, that's what I did right there. That's why I said equal to 180. So you got to be careful now. I'm telling you. Easy to make mistakes. Walker, are you good or not? I added. Come on, Walker. This is x plus 5. Right there.
Oh,
Somebody else. How much time do we have? I feel like I'm getting low on time.
39.
We got at 39?
Oh, no.
Okay, so we got 15 or 16 minutes. Okay, somebody else. Yeah, let's look at 39 now. Now on this one, it's just the angles add up to what? True. Nothing special. It doesn't matter. It doesn't matter. All I want you to do is say yes. That makes sense. All right, the angles of a quadrilateral add up to 360. It's not a big deal. Sometimes you don't see it. That's why I'm saying you got to practice. I'm telling you. All right, it's pretty easy, but you can make mistakes. Somebody else. Anybody on this page? Everybody's pretty happy? It's whatever. I don't know. I try to make it similar to the review. All right, and I've told you in the past, they give me A, B, C, D, E tests, and I just give you an easy review and a hard review, mix them up, and then I do the one in the middle. That's what it is. And I'm telling some of you guys are cutting corners, and you're going to be sorry. I'm just telling you. All right, you got to be working. You got to be trying. You're not just going to automatically tomorrow figure it all out while you're taking your test. That's why I'm asking. Anybody have any issues on this page? 40. Here we go. The sum of the measures of the exterior angle. This is a trick question. The sum of the exterior angles is always what?
360.
Always 360. Agreed? Right, if you want to find the interior angle, to me, the quickest way is take 360 divided by the number of sides and then subtract from 180. I think that's the easiest way to do that.
Oh, that's
It's so much easier. Right, that's why I'm telling you the exterior and the interior add up to 180. It's so helpful if you know that. All right, then that n minus 2 times 180 divided by n, there's not as much work. There isn't as much work. All right? Anybody else? Scrolling down a little bit. Graphs. Uh-oh, yeah, this was kind of a mistake. 50, the question is not there, so make sure you realize. Yeah, it's on the other page. So. 50? All right, so let's look at 50. All right, now, remember, rhombus. Very important. The diagonals of a rhombus are perpendicular. You agree with me? If they are perpendicular, that forces this to be 68 degrees. Now what I'm trying to tell you is this. Those are 4 congruent triangles, right? So that angle 1 has to be what? There you go, 68. All right? All right, somebody else, just go ahead, fire a question if you want. I don't care what page it is. We're getting down on time here, so nobody has any questions. All right.
Oh, could you do the formula for like when you use the 360 to find the integers?
Yeah, so if let's say they gave me like a 10 gon, I would just do 360 divided by 10. 36 is my exterior, and then 180 minus 36 is my interior. Now, if you do n minus 2 times 180 divided by n, that would be the same answer. All right, that would be the same answer. All right, I just can't emphasize enough, guys. Practice.
How do we find the number of sides?
What are you? I don't know which question.
Okay, for example,
Like which one?
number 3. Just find the number of sides.
This right here. The measure of each exterior angle is 18. So 360 divided by 18 is the number of sides. That's all there is to it. You have to know that relationship. What?
Let's go to the last
The very last problem? Oh, yeah. This is nice.
But I'm just curious. Is it for like number 4 and 7? Is there reason converse
Did I not give you the answer for that? And that's number 60. Yeah, so the only thing I can do is we just have to, this is 61, sorry. You're right, sorry. All right, 61. And there's nothing down there. Okay, so the best thing I can do is, it's kind of hard for me to look at a proof and just say that's the answer. Right, so we got a few minutes, so let's just try to fill it in. All right, so ABCD is a rectangle, or a parallelogram given, right? And then it says AD, so I'm going to mark AD, which is kind of hard to mark, but I'm just going to do this. AD is congruent to BC. That's, yeah, definition of a, well, it's not really the definition of parallelogram. Definition of parallelogram just says the opposite. Well, here I would honestly just say opposite sides, right, of a parallelogram are congruent. You with me on that? The definition of parallelogram just basically says the opposite sides of a quadrilateral are parallel. All right, then we prove that they're equal. You hear me? Then it says that PA is congruent to RC, so I'm going to mark that, which is given. And then PD, PD is congruent to what? Wow. I don't think that. Yeah, I see your point right there, kiddo. To me, I would need more steps between that. Well, I mean, yeah, but it just seems to me like we would have to say that PR or BR plus RC is equal to BC segment addition postulate, right? Right, because we're trying to show that PD is congruent to, yeah. So again, I don't think that's a single step there is what I'm trying to say. Right? I don't think it's a single step. I think we'd have to do some more. See, that's why I don't like, sometimes I like to just write the proof myself. You with me? So if I, go ahead.
It says triangle QBR equals SDP.
Where does it say that?
Number 9. Yeah.
Yeah.
But you have to use.
But then you have to use this triangle right here to find that.
Maybe they QBR is congruent to yeah, I just feel like, let me erase this real quick and let me tell you what I think. Because it's a parallelogram, yeah, see, I could say this angle is congruent to this angle. But there's really, I just don't know why they said that's a one-step thing. Here's how I would have to say it, you know. You would say that because AD is equal to AP plus PD, do you agree with that? And then down here you would say BC is equal to BR plus RC, right? So they're equal. So then you would say, because AD is equal to BC, then you would say AP plus PD is equal to BR plus RC, right? And then RC is equal to this was AP and RC, so then RC plus PD is equal to BR plus RC, right? Then subtraction, PD is now equal to BR. Do you agree? That's how I would do it. All right. So I don't like what they did there. So now I know they're congruent. Agreed? And what I'll do is I'll just say, see this process right here. All right, now why is AB congruent to CD? Yep. Opposite sides are congruent. And then why is BQ congruent to DS? Given. BQ is congruent to DS. But we could have. Yeah. So 7, AQ is congruent to CS. That's pretty much the same thing we did before, right? Yeah, so it's the same as really this, just at different sides. Yeah, I think, see, and that's why I'd rather just do that on my own. Does everybody see that? Because I don't like the way they did it, right? Because let's look right here. Let's look, see if I can summarize this a little better. All right, and like I said, you don't have to do this 61. All right, but let's, what they're trying to do is, the idea is to prove that this is congruent to this, and prove this is congruent to this. So all we're doing is we're proving triangles SRC is congruent to QPA, and SDP is congruent to RQB. Does everybody agree with that? And we already know what? We already know that, well, we don't know that, but we know that this is congruent to this. And so if we prove SD is congruent to QB, and we prove BR is congruent to AD, then we know that those sides are congruent. And it's the same for the other side. Do you agree with that? All right. Yeah, I don't like that. I should remember to cross that out. Yeah, I don't know why they thought that was a one-step deal there. Now, it says VW is a rectangle, so if it's a rectangle, then we know these angles are right angles, correct? And if it's a rectangle, we also know that's congruent. What? We also know that this side is congruent to this side, right? And it says Z is the midpoint, so that means this is congruent to this, right? No, those are just corresponding parts, right? The triangles are congruent by side angle side, right? And then YZ is congruent to XZ by corresponding parts. Do you see that or not? Right? Because VY, let's just say this, VY is congruent to here. That's the definition of a rectangle. This is congruent to this, definition of midpoint. All this angle is congruent to that angle because all right angles are congruent. Triangles are congruent, side angle side. And then CP, CTC. That's kind of easy. All right, please, guys, review. Please review. How much time do we have? Not much.